Hi everyone. This is our part two lesson on sine and cosine graphs. And in part one, we talked about what a sine and cosine graph look like first. And then we talked about amplitude and we talked about period. The next step is to talk about what's called phase shift. And a phase shift is basically what you call a horizontal shift whenever you're dealing with a sine or a cosine graph, just has its special name. So if you take your sine or cosine graph and you just slide it to the right or to the left, we call that a phase shift. Now when it happens is when you add a number to the variable inside the trig function. So to kind of summarize parts 1 and 2, we said if you take your trig function and you multiply the function itself by a number, that's the amplitude, that's the height. If you take the x inside and you multiply that by a number, that adjusts the period, makes it longer or shorter. Well, now we're saying if you take the x and add a number to it, it's going to shift it to the right or to the left. So for example, if I asked you to graph, instead of just sine of x, if I asked you to graph sine of x plus pi, that plus pi right there tells you to do a phase shift. Now remember way back in chapter 1 when we did our horizontal shift, which is basically what we're doing right now. We said it's kind of backwards. Whenever you have a plus, it shifts to the left, and when you have a minus, it shifts to the right. That's happening here also. So sine of x plus pi would actually phase shift the graph pi units to the left, and a minus would shift to the right. So for my second example, if you have cosine of x minus pi over 4, the phase shift is pi over 4 units, and it would go to the right for the minus. So the phase shift is essentially the same as the horizontal shift that we talked about way back in chapter 1, where if you're adding or subtracting a number to the x inside your trig function, it's going to shift right or left. And just remember, it's kind of backwards. It's like the opposite of what you'd expect. Pluses to the left and minuses to the right. Now there's one thing I want you to be careful of. If you do both a period adjustment and a phase shift, the number in front of x, which adjusts the period, has to be factored out first. So for example, if I asked you to graph sine of 3x plus pi, you might look at it and say, okay, well this 3 here, that's going to adjust the period. It actually makes it 1/3 the length. That's what we learned in part 1, and that would be right. Now this number here tells you that there's a phase shift, but because of the 3, we're not seeing exactly what that phase shift is. So the phase shift would not be pi units here. What you have to do is factor that 3 out. Imagining yourself taking, so you take that 3x plus pi, you factor the 3 out front here, and that's the same 3. So that part I said was right from the beginning. The 3 is going to make the period 1/3 the length. But after you factor that 3 out, this is the actual phase shift. So the actual phase shift here would be pi over 3 units to the left, because you end up with a plus pi over 3 there. And then the period, which I kind of mentioned earlier, I said if you take your regular period of 2 pi, you divide it by 3, or you make it 1/3 the length. So that's how phase shift works, and I said just be careful with that. When you're doing a phase shift, if there's a number in front of the x, you got to factor that number out first to see what the phase shift is going to be. All right, now the other thing I want to focus on for part 2 is word problems. I mentioned right at the beginning, I said we're going to learn all 6 trig graphs, but we're going to really focus on sine and cosine, and this is the reason. Sine and cosine graphs are very common in applications or in word problems. The other 4, secant, cosecant, tangent, cotangent, those are good graphs to know, but they're definitely not as common as sine and cosine. So you're definitely going to see sine and cosine graphs when you take the AP Calculus test next year. You're definitely going to see sine and cosine in your physics class, whether it's physics, honors physics, AP physics. Sine and cosine graphs are a big part of both of those classes. So I want you to be comfortable with them, and I want to show you guys an application, a word problem, and how it can apply. Okay, so what we have here is a mass suspended from a spring that's pulled down a distance of 2 feet from its rest position. And then basically you let it go and it starts bouncing up, down, up, down, up, down. That's a word problem, a real life way of creating what we called an oscillating situation, which creates sine and cosine graphs. So before I finish reading the question, let me kind of draw a picture of what we have here. Let's say that this right here is my spring, and there is our mass that's hanging on the spring. Now, right now, it's at rest. And at rest means I hooked it to the spring, I hooked the spring to the ceiling, and I just let it go. Maybe it bounces a little bit, but I don't touch it until it stops. So it's just hanging there. Now, what I'm going to do is I'm going to pull it down 2 feet from that spot and then let it go. And it says it's released at time equals 0 and allowed to oscillate up, down, up, down, up, down. So what I'm going to do, I'm going to take this, its position of rest, and I'm going to make that my x-axis. And I'm going to make that 0. That's where the height of that thing equals 0. Then this becomes our y-axis. And you know what, I said x-axis, let's call it t, because they said in the question t equals 0. So right there where the spring is hanging, that's where t equals 0. So I'm going to pull it down 2 feet. So let's measure down 1 and 2 feet. I'll call it -2 right here. So I pull the weight down to this point right here. I let it go, and it's going to oscillate. And by oscillate, it means since I pulled it down 2 feet, it starts at -2. It bounces up to +2, down to -2. +2, -2, up, down forever. Now, realistically, the weight would kind of slow down and eventually stop. But we're going to, for the word problem's sake, just pretend like there's no friction, there's no drag, and this thing's going to bounce forever. So as time passes, instead of showing the weight as just going up, down, up, down, up, down, as time passes, we're going to show it up, down, and you're going to end up with a wave graph like sine or cosine. So basically, at t equals 0, if I let it go, imagine moving to the right is time passing. It's going to go up to +2, back down to -2, up to +2, back down to -2, and it's going to keep going like that. So there's your wave graph, sine or cosine. And it is going up to +2 and down to -2. All right, so I got my picture. Now let's finish reading the question. If it says, if the mass returns to this position means where you pulled it down 2 feet, it returns to that position after 1 second. So right here is the point where it returns to the -2 position. What that means is this right here is 1 second. It's 1 on the t-axis. So based on that information, we want to find an equation that describes its motion. And so when I look at this graph, my first step is to decide whether I want to use sine or cosine. Now, if you think about sine and cosine before we change them or anything like that, sine normally starts at 0. Cosine is the one that starts up at +1. So for me, any graph that starts at 0, I use sine for. If it starts anywhere else, I use cosine for it. So for me, for this one, and you actually could do this one with a sine graph, but then you'd have to do a phase shift too, it would be harder. So I'm going to use cosine. I'm going to kind of space it out and leave myself some space to work here. Now, let's start with amplitude. First thing I notice is that this graph is going up to +2 and down to -2. So my amplitude is going to be 2. But we have to make one more change to that. Because if you think about it, cosine doesn't normally start at a negative number, like -2. It normally starts at a positive number. So if this were just 2 cosine of something, it wouldn't be starting 2 feet below rest, it would be starting 2 feet above. So I'm going to make this a -2 instead of a +2. A -2 cosine x is a cosine graph, or cosine t, or whatever the variable is. It's a cosine graph with an amplitude of 2, so it's taller than normal, but it also starts down here at -2 instead of up here at +2. All right, now the other thing I want to figure out is the angle. So what I'm going to do, I'm going to put a t in here, but I'm going to leave a space in front of it because we are going to need to multiply. And the way I know that I need to multiply is normally that one full cycle of cosine takes 2 pi seconds. And it says in the question here it takes 1 second. So this 1 second right here, if that was 2 pi, I would be done. I would say, okay, my answer is -2 cosine of t, and I'd be done. But I need to figure out what the number is that takes our regular cosine that goes from 0 to 2 pi and shortens it so it only goes from 0 to 1. So if you go back and think about the way we found the period, we took the number in front of x, or in this case t. Now for the notes, I called it b because that's what it usually is in most textbooks. And I said to find the period, you take your normal period, 2 pi, and you divide it by that number. Well, what we're saying is 2 pi divided by whatever the number is, that's what we're trying to find, has to equal 1 second. So the question you're asking yourself is 2 pi divided by what number equals 1? And this one you can kind of do in your head because 2 pi divided by 2 pi is 1, any number divided by itself. But if you couldn't do it in your head, if it was like 2 pi over b equals 2/3 or something, just solve it. Just say like, okay, I want to multiply both sides by b to cancel that out. 1 times b is b, and you basically solve that way. But either way, this b right here at the bottom is 2 pi. So I'm going to put 2 pi in for b, and that's it. That's my graph. I'm done. So what we've done with this word problem is we worked our normal question backwards. What our normal trig graph question is, I give you the equation and you graph it. What we did here, we took a word problem, we used it to draw a graph, and then we used the graph to come up with the equation. So you have to have a real good understanding of things like amplitude and period to be able to do that. If you're just kind of like memorizing, okay, every time I want the period I do 2 pi over b, and every time I want amplitude it's this and that, you might not be able to do this type of question because you got to really understand what each number does and what you're doing to your graph to be able to work the question backwards. And that's real important with the application type questions.